413, storage encryption techniques. You have the lab open. Let's go. Data at rest, transit process. Who cares? I open up the lab. Let's go to control panel here. So I'm going to hit this Windows thing. I'm going to go to control panel. Going to open this up. I want to search for administrative tools and double click computer management. So administrative tools and double click computer management, which is right here. Then you wait. And then we go to storage, disk management. And yay, C drive, E drive, and system reserve. So hey, we're seeing all this. Yay. We have our physical disk, we have volumes on the disk, and then we can break those volumes up into partitions. Cool. If you want to know those differences, that's great. Let's see what it looks like on our Explorer. So if you open up this window, we have our C drive, we have our E drive here. Two different drives on this computer, right? What I want to do is first, I want to try to encrypt this drive. Encrypting a drive here, I'm going to encrypt the E drive. So we're going to use it using a program called BitLocker here. So let's open up BitLocker by hitting this search thing and start typing BitLocker. And you should see BitLocker pop up, manage BitLocker. You're going to click on this. Now what you're going to click on next, what lesson are we on? We're around 9 here. So we're actually lock E. So click on new volume E BitLocker off to expand it. And then we're going to turn on BitLocker for volume E. Now when this pops up, we're going to give some password. Make it an easy password. I'm going to make mine literally password. Just password. You probably have to do a certain amount of characters, otherwise it's going to give you an error message. For now, it's fine. We want to back up with a recovery key. So not just the password, we want to have a backup recovery key for our drive. We can, in real life, we could save it on USB. We could print it out if we wanted to. But for now, we're going to save this file. Now you hit save. I'm going to save it to my desktop somewhere. And I'm going to keep everything to the default with this default file name. Notice this default file name says BitLocker recovery key, and it actually puts this key or something in there. Let's say save. Do you want to save your recovery key on the PC? It's a good idea to have more than one recovery key. Okay, we're going to save it, okay? And then I'm going to hit next here. So yeah, I could save it on USB too. In real life, you probably want to have a few different ways, because if you lose it, that's it. You don't have a password, don't have a recovery key, you're going to either have to crack into it or just delete everything. So we're going to encrypt the entire drive. Yeah, we're going to choose that one and then hey, start encrypting. So stuff's going to happen in the background. This takes a little bit of time to go through the whole process. But let's do other things. So back on the desktop, open that recovery key. So if we look on this recovery key, I'm going to close this thing here. The recovery key was saved here. Notice here it's got that default name. I can open it up. And there's a few pieces of information inside. Open the recovery key and observe its contents. So verify this is the correct recovery key. Compare the start of the following identifier with the identifier value displayed on your PC. I don't know what the identifier value on my PC is. Is that like a MAC address or is that something? I honestly don't know. Is it compared with this? If the above identifier matches the one displayed on your PC, then use the following key to unlock your drive. So I can use this as my key. This is identifier. If it doesn't match the one displayed on your PC, then this isn't the right key to unlock your drive. Try another recovery key. How do you identify a system could contain more than one encrypted drive? So there's some number. Maybe that's a MAC address or some other Windows. Maybe it's a Windows thing. I don't know. It doesn't say in here, so I don't know. I don't know. Does it say? No. I want to type that recovery key in here. So go ahead. We're going to copy this. Control C. Now, if you want to paste over, I think I can delete everything. Does that actually paste that? Yeah, it did. Control C, Control V. I'm not adding things in here. But that's it for that file. Notice that it has the format of the default file name. This is going to come in important later in this lesson. So now that we've done all this, I actually have to, for the encryption to take effect, we have to restart the computer, the lab. Now, it's a security lab. We don't reset the lab. We have to launch PowerShell and do shutdown /R. So PowerShell is the blue one right here. Go to shutdown and go /R. You're about Windows shutdown less than 1 minute. All right, so I'm gonna pause the video while it shuts down. Okay, it's disconnected. We're gonna hit the reconnect button. You might have to hit it a few times. Just keep going until it works. All right, took 2 times. So let's see if we open up this file explorer. Notice the E drive is locked right here. I can't access. Oh, I never saved any files in there. I should have. I skipped the lesson of dragging some stuff in there, but honestly, it doesn't matter. One thing to notice here, if I want to get into there, I'm going to need to use a password. Now, if you know your password, and I type password for me, I can click this. I only did one S. Unlock, and it's going to unlock that drive so I can look inside of it. I never actually saved things in there. I should have last time, but oh well. But that's how it works. We can reconnect, all right? Moving on, recovery keys. So you forgot. What if you forgot your password on that protected drive and you lose access to its contents forever? Only the password or recovery key will be able to get it back. Imagine that you've lost your password. What do? Well, maybe it's saved on a file, but how do you find that file? I know it's on the desktop, but what if it's like buried somewhere in the computer? And like, or this is some computer you don't know where they put it. You think maybe they put it somewhere on their drive. So we're gonna use a program called grepwin, which is kind of a fancier search thing. I know, like in Windows, you're like, can I just search up here? But this search is not as robust. There's some features that aren't available. So we're going to use this grepwin tool right here. So go to Desktop Activities A413 and go to grepwin. 413 grepwin right here. So this is a fancier search tool here. So let's see how this works. There's a few things in here. We can use this asterisk as a wildcard command. So one thing we know if we want to search for the file names, the default file names, this is why I go back to this is important. It puts a recovery key in here, but notice how it has this format of a certain amount of characters. So if you look at this, it actually does like 8 characters dash 4 dash 4 dash 4 dash, I think this is 10, something like that. 4, 11, or something like that. Okay, so you see these recovery keys kind of have a format, right? And I can use that as a way to search. So that number is going to be different every time or different for different computers. But I can search using asterisks for those wildcards and dashes in between. So that's what I'm going to use in grepwin to try to find that file. Like maybe I don't know this actual recovery key, this number here, but I know what the default file name looks like. So the way we do this is I want to search, hit the triple dots. We're going to go to my C drive and go inside users. We're going to assume it was saved in users here. Okay, just for purposes of this activity. And then you're going to put in the file names to match this right here. So those triple dots, I'm actually going to have to paste it into here. This is Control-Shift-Alt. And I paste it in here. And then we can search it, file names to match right here. So with the asterisks, the dashes represent these dashes in between, but I know there's a certain amount of characters for the keys. Okay. And it's like the first group, this is going to be like 8 characters. There's 8 stars, dash 4, dash 4, dash 4, dash, I think it's 11 right here. So hit search. And guess what? I do find that bit recovery key. It's right here. And it says, oh, where is it? It's on the desktop. Duh, put it on the desktop. What's neat is I could like include hidden items if I wanted to. It's a fancier way to search, especially if you use like asterisks as the wildcards there. All right. And I found that key. So this kind of shows you the default file name might not be a great thing to save your stuff. So what if this wasn't the default file name? I'm actually going to go hit F2 and call this, let's see if I called it secret file, recipes. See, I want to hide this, say, oh, this is going to be recipes right here, right? So now I search now, I don't find it, right? I changed the default name. Well, there's other ways to search for a file. I can search for the contents inside of the file. So like, for example, I know that the recovery key is going to be in this format. Recovery key is going to be 6 numbers, dash 6, dash 6, 6, 6, 6, 6, 6. There are 8 groups of 6 numbers with a dash in between. So I know that's the format of the recovery key. So I can use that to kind of find the patterns. Now, to search for recovery key contents file, what pattern or words should you search for? I'm going to say that recovery key. We can search for the words that are always in the bit recovery files, such as BitLocker. So here's the thing here. You know how we use asterisks for wildcards when we search for file names? You can't use the asterisks for contents. We're actually going to use periods. Search by the contents recovery file instead of the file name. Use grep to search for patterns in a file. Use a different wildcard, the dot character. So the dot character is a different type of wildcard. So dot is going to work the same way. Actually, like doing this as asterisks didn't actually work for some reason. And this was kind of tilting me. last time. So I say, okay, we're not searching file names anymore. So I'm going to go in here and go delete. I want to search for inside of here. Let's see if I did. Like stars don't work for some reason. You have to do dots. Dash. Dash. Okay. So we said there's 8 groups of these. That's 4, 6, 8. So you have to do dots for some reason. That's kind of annoying. I don't know why it's dots, not asterisks. I've always learned like the wildcard character was asterisk. So, but here's what you're doing. Delete everything in the file names. Put this in the search, still in the users. Now let's search. And it found it. Recipes.txt. So what this does is it's going to search what's in the files for that pattern. One thing to note, what if I just had this pattern? Would it still find it? What if I... Yeah, it still would find it. What if I... Wait, if I put an extra dot in there, would it find it? It will not find it. But so notice here, like I didn't need to have the whole pattern. So if I didn't know how many of those groups, I know there's like 6 numbers and a dash. I could just done like a few of those. Maybe just do this. Okay, so if I do this, it finds 2. It finds its recipes, but it also found this Bing thing. Now that's probably just, it's just a very interesting coincidence right there that there's some text in there that has that. But they're recipes, and I go, oh, what's recipes? Oh, it's actually my key. So try those things out. Open the file in the search results pane to confirm that's indeed your BitLocker file. So I did, and I opened it up, it worked. So this is another way to search. Okay, encrypted. So in this section, we encrypted an entire drive using a trusted platform module, specifically BitLocker. You've unlocked the protected drive. And then after losing the password, we searched and found the recovery key. All right. So now we've done all this. Now I want to try the next part of this, encrypting a container. So a container is just, it's kind of like a part of a drive, right? So we're creating like, we're just taking a chunk of this drive and then we are going to convert it into a container, right? Into like a new drive. So watch how this works. So we're gonna open up a different program. I'm gonna close this, just close everything out. Close this guy out too. We're gonna use a different program called TrueCrypt right here. We're gonna create so open up this thing, start typing true. And see this program called TrueCrypt, we're gonna open that up. So TrueCrypt right here, we can create a new volume. See all these drive letters? Okay, so our computer right now is just using the C and the E drive. D, F, why to skip D? Sometimes D is like kind of your disk drive for a while. So maybe sometimes that's why you skip the D. But yeah, you can choose any letter you want here. So what we're going to do is we're going to launch utility, type TrueCrypt, create volume. So we're going to make a new container here. We're going to keep the default values, create this, so hit next, just hit next. We're going to select the location. We're going to put this in our E drive and we're going to name it encrypted container with a capital E and C. So I'm going to say select file, go to my E drive. We're going to put it in the E drive and go encrypted container. All right, go to next. We're going to hit the next thing again, leave this. Now this is where you change things. In step 32, it says make it 50 megabytes and click next. So we get to set the size, the volume. How big is this container? We're going to say 50 megabytes. The maximum free space on E is this much. So 50 megabytes. Okay. We got to make a password for this. Now, this is important here because we're going to be, you want to make this a 1-word common password because we're going to be decrypting this later. So don't make it some weird thing. And hint, use something that's early in the alphabet to make this take less time. So I'm just going to use Apple. You want to use something else? Let's use another A word. I'm going to call it animal. Animal, just to show you that it still works. All right. Do we want to display the password just to verify? Cool. Warning, short passwords, we recommend. Are you sure you want to use a short password? Yes. For the purpose of this, I'm going to use it. You know what's neat here? Every time I move my mouse, this is kind of like randomizing the numbers somehow when you move your mouse. Don't worry about this. Just hit format. So now it's going to create an encrypted container. And then after we do all this, we're gonna hit exit. So don't hit next because you do another one, just hit exit. Now, we're back to TrueCrypt right here. We've created this container. I want to show you what that looks like. If you open up File Explorer, you go to the E drive right here. Notice I have a file called encrypted container, and its size is 51,200 kilobytes. That is 50 megabytes because 1 megabyte is 1,024 kilobytes. About 1,000 roughly, 1,024. So that's why it's not perfect. So there you go. I got my container. It's in there. Now, what I want to do next is I want to mount that container into one of these drives. All right. So I've made this container. Great. It's just a chunk of space, but I want to be able to like put files in that chunk of space. So to do this, I have to mount it as one of my drives on here. So with TrueCrypt still open, let's say I make this, you know what? I'm making my G drive. I'm just going to be weird. I'm going to go to my G drive, and then I'm going to choose that encrypted file. So I'm going to go to the E drive, encrypted container, and you have it all set up here. I want you to set that up, click whatever drive you want, and then hit mount. I'm going to say mount. Now you have to enter the password. You're like, oh, what was it? Animal. For me, I want to see that. Did it, or so I hit OK. And notice right down here, I have a G drive. And this is like empty space right here. It just added as soon as I mounted it on that list. So we're on here, and this tells information. Like I can make multiple drives. Now what I want to do is I want to drag some files into there. So I'm just going to take some of these files. We're going to drag it into this G drive. Now the G drive has a few things in it. Cool. So this is going to simulate just saving some stuff right here for this G drive. Great, it's in there. It's in this container. I put stuff in here. Now I want to dismount this drive. I'm gonna, like it's mounted as a G drive, I want to take it away. So it's not in there anymore. But all that stuff will still be saved. So I have this selected right here. Notice that mount button is now dismount. So like you can do there, it says mount. Now it says dismount. I'm gonna hit this. Boom, dismounted. It's no longer here. That Explorer went away. Notice on Explorer, the G drive is no longer there. We still have this container. It still has that stuff in it. See, what's kind of neat, like what if I wanted to like put in the K drive, mount that file again, password, animal, have a K drive. Guess what? Those pictures are still in that drive. Kind of cool. Just mount that again. It went away. Pretty simple. Kind of cool. So this is a way showing that, hey, if you have a container, how to mount and dismount this, right? All right. Now, hey, what if you lose that password to that container? You're done for. You're done. There's no like separate key. How do you get the access to this? This can be dangerous. Well, sometimes we can use programs. Like if you have bad passwords, you can use programs that can kind of crack the password. Basically, they're just going to guess. Use like a dictionary tag. That's why we kept it simple. We're going to use a tool called John the Ripper. This is real stuff that can be used to crack passwords using dictionary tags. That's why back to Unit 1, we said common passwords are easy to break. Just give enough time, programs can just keep guessing till they get it right. That's why they sometimes recommend you do like, mix up letters, capitals, lowercase, add some symbols in there, do more than one word. That's some of the ways you just break in is because people have simple passwords. Open a command prompt. Okay, so we're going to actually run this program. It runs a little differently right here. I'm going to close all these. We're going to open this command prompt. That's the black one right here. Now, we're going to change the directory to this thing. I wish they would actually just tell you what to do, but they don't. I'm going to copy this line. And if you remember change directory, I'm going to go paste. And we go CD space, right click, and paste. Now it changes directory to John180 J1W /run. Okay? So now we want to type TrueCrypt _volume2 John.exe. So I'm going to copy and paste that again because it's so much easier to do it this way. So if we just paste this program, I say run. And then what does it do? Warning, couldn't compute. Please report the problem, utility, blah, blah, blah. Okay, we had a problem. So you don't just run the problem this way, or you don't run the program this way. What you have to do is you have to use the full path of the container. So there's a little formatting thing. You can't just run the program. You have to do run the program. Then the next thing you have to put, what do you want to decrypt, which is the container you're trying to decrypt. and then you have to specify where do you want to output it to. So what this is going to do, it's going to TrueCrypt right here. It will, what does this actually do? Well, let's just run this first. So just take this line here, copy this, and then we'll explain what it actually does. Paste it. Let me paste it here. And then, okay, it might give you some warnings. It's fine. It ran the program. Now, what does it actually do? It'll include some warnings. What it's doing is your password is actually like saved at, it doesn't save the password as plain text, like, oh, just my password's animal. What it does is it turns that password into a hash value, which is like a big chunk of information. Or a hash function called hashing is a computational process, converts data of varying size to a fixed size. So yeah, you might have an 8-word password, but it converts that into like, because all the hash values are going to be a certain chunk of stuff. It'll convert that to something that's a bigger chunk. All right. So it's basically converting the password that you know in plain text to something that looks a little weirder, right? But it's not the actual password you type in. It's weird conversion. So hash is a fixed amount of text that represents some other data. In this case, the other data is a password. So it represents that password. So what it's doing is it's extracting the, since it knows that, hey, in the container, that hash is in a certain part of that container, like it's probably like towards the beginning somewhere in that big old file, it's probably what area of it, it can just say, hey, take all the data in that area and save it as this hash value. All right. So if we want to see what's in there, we're going to go type and then hash underscore values.txt. So we go type hash values.txt because that was my output file. And you'll see all of this text, a lot of it is the hash value. A lot of stuff in here. All right. This is the password of animal is saved like this. So now that you've done that, you can see what it looks like, right? Now, how do we crack this? Well, we have to run the John the Ripper program. And here's how you do it, just right here. So copy and paste this text in 47. What it's going to do, this word list, password.list, is basically going to run a dictionary attack. So check every word in the dictionary and compare it to this and see what breaks. So we copied that. Going to paste it in here, going to right-click paste. And then this should take some time. Now, this might take a little bit of time. This is not going to be instant. We're going to sit here and watch. And it's not going to like tell you when it's done. It's just, it's kind of hard to see. But you'll see some extra text will pop up there. Oh, there it goes. So that's why I did an A letter at the start of the alphabet. If you did like a Z letter, it's going to take a lot longer. Animal. So this is running blah, 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 blah. You can't, it's hard to even tell that's actually running, but it is doing stuff in the background.
Sorry, I'm having trouble.
Ignore that. Come on, watch. And then it said, oh, found my password. It's animal for encrypted container. There we go. It's done. So I got my password. So that's just showing you that this John the Ripper program can actually rip the passwords out of here, especially if you use something simple. All right, when you see the password you want to see, the password for, you can type Q or Control C. So I can type Q, I'm done. And I'll abort it because I found the password already. And I'm done. You can view the hash values and verify all successfully cracked password using john.pot. So we can go type john.pot. I'm just curious. Oh, it said for this hash, it found animal. Okay, cool. It's like a history of what it's done. So there we go. We cracked a password using John the Ripper. Yep, real programs. That's why if you do simple passwords, someone could just run a program like this. Yeah, using TrueCrypt, and you have a one-word password. Think you're clever? You know, it just takes time. I mean, you could, and if it's just more than one word, I mean, eventually these cracks could give them enough time. They could eventually get it. Enough time, and that's how complex you have your password. Eventually they can crack it. All right, encrypted files and applications. Certain applications have built-in encryption. Okay, so what about encrypting files? This is the last part of this lesson. We did containers. Well, files can have encryption too, right? You've had files that you try to open and says, oh, it's password protected. Like you can even password protect sheets on Google Sheets or your files on like Google Docs files, right? You've had password protected maybe Office files like Word files or PDFs, zip files. We can encrypt those. Typically, the file encryption is typically weaker than system encryption. However, since the encrypt and decrypt, the file size remains small and easy to transfer to other people's computers. So, but we're going to demonstrate that, yeah, we can use these programs. Again, if you have a weak password, we can do it just the same way. So we're going to go to navigate to C-docs right here. We can actually close this. Navigate to C drive and -docs. Now there's a file in here called encrypted. I'm going to double click this. So encrypted is a PDF and it wants a password. I want to get this password. I don't know the password. So what do I do about this? I know it's a PDF file called encrypted. So I want to try to open it up. I want to decrypt it. So, I shouldn't have closed the command prompt. I did. Oh, I have to do this CD thing again. It's all right. You shouldn't have closed it. Oh, well. So I'm going to do this. And then we're back to this one. Now, list the contents of the folder. Now, I thought you had to do ls for list, but that's the Linux command. You do dir, dir, to list everything in here. Now, this part of the lesson is like, which of the programs in here? This is a PDF. Last time was a TrueCrypt and container. Remember that file name was called, to John the Ripper to decrypt it, was called TrueCrypt Volume 2 John. TrueCrypt Volume 2 John. So what if I wanted to decrypt a PDF? Well, okay, it's probably going to have PDF in the name. So like, which one of these files do you think does PDF? Okay, so you look around here. Maybe you do John, not quite. Key store to John, keychain to Tom. That's probably the decrypted keychain. Let's go down to PDF. PDF to John.py. PFX. Okay, so it's probably this, and it's actually a Python file this time. All right, so we're going to have to run a Python script. So let's see. Enter the name. So I'm going to go, it's PDF to John.py. That's what it looks like to me. PDF to John.py. All right. So we want to run it as a Python command. Now, it's not just typing that. We have to do this format. Python, program name, full path of file, output to the hash values like we did last time. So here's how I do this. If I had to type all this in, I'm going to go Python, and then I'm Python, and then PDF to John. And then we do the container, just like we did here. We have to do like this part. This container, and then I'm going to call it hashvalues.txt. I don't care. Sure, I'll call it hashvalues.txt. Doesn't matter to me. So I'm going to follow this format, go container. Wait, it's not container. Whoa. Okay, we have to get to this encrypted file. So the encrypted file is in C/docs. So C, or that's / docs. And then / it's called encrypted.pdf is the name of the file. And I got to output it. I think it's that caret. And then we can make it hash.text. Just make it hash.text, whatever you want to call it. So there's my format. And then it has now run that program. Now, do I know it did it right? I'm going to do dir again. See if I see hash.text. Hash.text, 230. So I think it did it right there. Now, if you want to see the hash values in there, so remember we do type hash.text, and then it would like print out everything in that hash value. And this kind of shows, hey, yeah, we encrypted this doc/encrypted.pdf. So it's a PDF file. Cool. And we can tell it's a PDF file, like it says it's PDF, this says PDF, PDF type here. Those are some kind of like hints right there. All right. So now we want to run the John program again and then try to find the password. So, well, how did I run the John program? You know, like, I forgot. I forgot too. We had to do all this. So is this line. So it's going to run it on the passwords. Now, I didn't call it hash values.txt. I think I just called it hash. Oh, it's not going to work. Got to call it hash.txt. That's what I named it. There you go. I run this. And you're like, whoa, that happened really quick. Is it done? Like, now look in here. Do you see the password? It's right here. So it's kind of hidden. Like this can be annoying sometimes. It doesn't say, oh, I wish this was like highlighted in a different color, but it's done. It's such a small hash. I mean, this is a hash, smaller hash right here. It found it real quick. So the password's dog. So I go back in here and I go DOG. And done. I have decrypted. I have cracked the password to this file. And if I want to, I can do that type john.pot thing again. Nah, I'm not doing that. So that's it, folks. We have decrypted that file. We have broken into the PDF. So, we broke into everything here. We show you how to use John the Ripper to break into an encrypted file, basically do a dictionary attack to test the passwords. That's probably going to be useful later in this project. We use John the Ripper to break into a container. And then we showed how to mount and dismount that container from the drives. And we showed you how to use John the Ripper to find the password. That's probably going to be important too. We showed you how to encrypt a drive, or in general, that was through like Windows, using, I don't think it used TrueCrypt, right? Was it TrueCrypt that did it? TrueCrypt maybe it did it? I don't remember. No, it wasn't TrueCrypt. It was BitLocker that we did it through. BitLocker. But there you go. Notice that we can break passwords with these programs. I mean, this was really quick. Obviously, if you had like a longer password, it's going to take more time. But hey, all it takes is time. What's this last thing? Cryptocurrency. One specific type of encrypted data. Cryptocurrency has become popular in recent years. Oh, really? Digital cash system. Data can be at rest, in transit, or processing. To make it secure, use encryption algorithms in all three data states. Compare cryptocurrency to traditional banks. Okay, blah, blah, blah. I'm sure. This is funny. Like, this lesson is probably a few years old. Like, I wonder sometimes, like, is this just too old? Does this just move so fast that I shouldn't even bother? I'm going to stop the lesson here.